Hello Year 9, this is our second lesson looking at the limiting factors of photosynthesis. We're using exactly the same title as we did last lesson, so we're going to go straight into looking at how carbon dioxide affects the rate of photosynthesis. Last time we looked at light intensity, we had our kind of introduction to how the practical works, the two different ways that we could collect that data, and we collected some data. If you remember, we drew a graph and then we drew some conclusions from that. So straight into data, drawing our table to collect our results in, and you can see there we've got sodium bicarbonate, which is a carbonate product we can put into the water with the pondweed, and it will increase the carbon dioxide in the water. And we can investigate that as a limiting factor. If you remember, referring back to the photosynthesis equation, carbon dioxide is one of the reactants. So if we can increase that reactant, then we should be able to increase the rate of photosynthesis. So we're going to take some time now to draw our table. And if you need extra time, then please pause now. Okay, so from looking at the change in light intensity, we found that the optimum light intensity was around 50. So I'm going to go on to 50 for this next experiment. Now we're going to be changing the sodium bicarbonate levels this time. This increases the amount of carbon in the water, and that provides carbon dioxide for the plant to photosynthesize. So we're going to start off exactly the same as last time, at 0.05. Again, I've drawn my results table, so I'll collect my data and then I'll add it to the original PowerPoint. So here goes. Again, once you get the general idea, 1.2, you don't have to watch me collect all the data. You can fast forward 1.5 to a slightly more exciting part of the lesson, 1.2. Okay, let's move it to 0.1 and collect some data. Quite a big jump there. 3.3, 3.9 and 3.7. Now notice I'm only changing one variable at a time. Okay, we can only have one independent variable going on at any one time, so I've just increased the sodium bicarbonate there to 0.15, but I did my light intensity, got my set of results 5.2, and now I've changed the independent variable 4.9, and it's effectively a new investigation to look at a new limiting factor, 6.2. Quite a varied set of results. We'll have a look at those in a bit. Let's go to 0.2 and 6.8, 5.2, 6.0. Let's increase again, 0.25. Now in an exam situation, 6.1, that anomaly will be really obvious, and 5.3, it will be a case of showing that you know that you don't include it in your calculation of the mean. 5.4, so you might have three results, you identify one is an anomaly, and then you don't include that one, you just add your two good results and divide by 2. So we're on 0.3 now, and we've got 5.4, 5.7, 5.9, and we're going to take it to 0.35, 5.9, 6.8, 5.4, and we're going to go to 0.4 now, 5.4, 6.6, oh, do it as the repeat reading. 5.8. Sometimes if you just click on the syringe to go in and out, it gives you the same result each time, so it's best to do repeat reading. Right, we're nearly there, 0.45, and let's collect some gas. 5.8. 6.2 and 7.1, and then we'll increase. Final result 7.1. Wowzers. 4.6. I think we can definitely say that 4.6 is an anomaly. 5.8, so I'm going to circle that 4.6. Not happy with that result. Okay, so I'm going to put that information back into the PowerPoint, work out a couple of the means for you, and then you can process the rest of the data. Okay, so now we've collected our results. Here are those results in the results table. I've calculated the first two means for you so that you can check those off, see that you're on track, and then finish calculating the means yourself. I think we can probably safely identify this result down here, the 4.6, as being an anomaly, so we can circle that in our results and not include that in our calculation of our mean. Now, a couple of things to make sure that we're getting those means done properly. The mean should be very similar to the original results. So you can see there we've got a mean of 3.6, and that's very similar to 3.3, 3.9 and 3.7. You must make sure that you add the three results together, press equals, and then divide by 3. And we're dividing by 3 because we have 3 repeats. In that final row there, where we're taking out that anomaly of 4.6, we'll add together the 7.1 and the 5.8, and then we'll press equals and we'll just divide those by 2. Okay, so here is our all of our results that we gained, and it's now your opportunity to calculate all of those means yourself using your calculator. If you need more time, pause now. So here's our set of results. I've transferred them into Excel. If you want to just use graph paper, that's absolutely fine. I've done this so that you can see exactly how that graph should look at the end. So sodium bicarbonate was our independent variable, the thing that we chose to change, and that always goes on the bottom horizontal axis of our graph, and the mean length of oxygen bubble produced in 10 minutes is going to go on the vertical axis. That's our dependent variable, the thing that we measured. Now, I've already played around with this data a little bit, and I'm just going to show you what I've done here. So if I go to just 1 decimal place, that data doesn't really show me very much. Okay, it shows me a general pattern, but not a huge amount. So I've gone to 1 decimal place to give myself a higher resolution of data and more precise data. And the reason I've done this as well is because when I type this in, where I've got this 6.0, it just read 6. So if I do that, then I've got everything to 1 decimal place. It makes it look nice, okay? I've calculated the 2 means here using my calculator, and the rest of them I use that formula that I used last time. So you can see up here, equals sum, open bracket, B6, which is this cell here, colon to D6, which is this cell here, and then close brackets and divide by 3 because I've got 3 results, so I divide by 3. Now, we'd identified that this result down here may well be an anomaly, okay, an anomalous result. So we're not going to include that in the average here, so I need to change this sum. So the way I'm going to do that is I just want to have B13, which is this cell here, and D13. So I'm going to change that colon to a comma, and then I need to also change that so that it's divided by 2, not divided by 3. And there you go, I've got my 6.5, which is much more in keeping with the rest of the results in this mean column. So next thing I'm going to do is I'm going to highlight the data that I want to graph. So it's the sodium bicarbonate and the mean. And then I'm going to go to Insert, and I'm going to click on the charts arrow, and I'm going for this one, which was I think the same one I went for last time, and there we go. And then what I did last time is I added chart element, and I added an access title for the horizontal, which is sodium bicarbonate, which was measured as a percentage. Okay, so that's just come up there. And then I'm going to add another chart element, which is the vertical. And I didn't do this last time, I missed it out, but I'm going to remember to do it this time. It's the mean length of oxygen bubble. Remember, we're using oxygen as our indicator of the rate of photosynthesis, because it is a product of photosynthesis. In 10 mins, and that was in centimetres. So there I've got that, and I'm going to take away the chart title. And there we've got, again, we haven't got that situation of being able to do a nice curve of best fit. So we do not want, I repeat, we do not want to join the points on our graph. We want a nice curved line of best fit, okay? Now I'm going to transfer that graph into our original slide, and we'll look at all of the questions we need to answer in order to do our conclusion. Like I said, if you've done this on paper or on Excel, either way is absolutely fine. If you need extra time, pause now. Right, final section then. So we've got our graph there, and we can see that at these early stages, as sodium bicarbonate increases, so does the mean length of oxygen bubble. Therefore, there is a higher rate of photosynthesis. And then we see we get this levelling out. Okay, and that levelling out kind of says you can add more sodium bicarbonate, which will inevitably cost more money, but it's not going to make any difference to the rate of photosynthesis. So it's at this stage here that sodium bicarbonate, carbon dioxide, is a limiting factor. And then beyond that point of 0.2, it's no longer a limiting factor. So let's look at all of our instructions of things that we had to achieve today. We've collected the data, hopefully we've plotted our graph. The independent variable is the thing that we change, and in this case it was the sodium bicarbonate, which helped us with the carbon dioxide levels for the pondweed. The dependent variable is the amount of oxygen that was produced, and to describe the relationship at the start, as sodium bicarbonate increased, so did the amount of oxygen produced, which then means that there was a faster rate of photosynthesis. Explaining the graph, I've kind of done that in the sense that I've related the oxygen concentration produced to rate of photosynthesis. So as this sodium bicarbonate increased, amount of oxygen increased, and therefore rate of photosynthesis increased until we got to that optimum point. This is our best point, okay? We call it the optimum. It means it's the perfect condition for that pondweed to be in, okay? And beyond that, so suggest what happens later, you can add as much sodium bicarbonate as you want. It makes no more difference to the rate of photosynthesis, therefore no difference to the growth of the plant. There's no benefit to it. So we'll stick with saying that our optimum, and you can mark it on your graph if you want, is 0.2% of sodium bicarbonate. So that takes us to the end of this lesson. We've now looked at two different limiting factors on the rate of photosynthesis, and next time we are going to look at the effect of temperature on photosynthesis. Hope you enjoyed that and got through the graph, slightly different from other lessons. Have a good day.